Hello Internet and fellow network engineers. My name is Maxim and I share network design ideas, tips and tricks with you on my channel. This video is the first out of 3 dedicated to Source Network Address Translation or NAT. Most likely you enjoy using this technology right at this moment. You may be on the lookout for a new design to increase performance or scaling of your existing hardware. By watching this series of 3 videos, you can even find a few tricks which can help you modifying your design to reduce OPEX while not degrading your overall scaling. The first video is focusing small-scale Source NAT solutions, which can be found in home office or small business networks. Hardware in my demo and designs are represented by Juniper Networks series firewalls, which is available in a wide range of models, from smallest fanless desk models like this one, up to the large chassis-based models with performance measured in terabits per second. Small-scale NAT solutions can be implemented using Juniper SRX branch series models, starting with 300, 320, 340, 345, and virtual SRX. I will start with briefly discussing technology basics, then we'll go over 2 design solutions, and I finally will show you a lab demo with hands-on and configuration samples. Let's start with some basics. The whole range of IP addresses can be separated into public address space and private address space. Public address space is the routable in the internet address space, which is being registered and owned by different companies and internet service providers, while private address space is a dedicated address space which is allowed to use for everybody in order to conserve the public address space. But there is a catch, so private address space is not publicly internet routable, and if hosts with the private addresses needs to communicate to the internet, this needs to be translated. This is called the Source NAT, or network address translation. So this is the whole topic of conversation in this video. And also public address space can be separated into portable and non-portable. Again, as I mentioned, public is very similar to like car license plates, which are dedicated and reserved and registered to certain companies. Portable address space, this is when company is using the address space which it owns, which belongs to her. And non-portable is something different, is like renting, for example, a public address space from an ISP, like a subnet from the internet service provider. In this case, you have certain restrictions how you can use this address space. This is just a general topology diagram for like internet, which consists of different networks, private and public, but the internet itself talks only on the public addresses. It means the green networks can communicate via green links because they are publicly routable. All the brown bubbles needs to be translated by some device, which is usually a firewall, and this process, when private address is being translated to public address, is called the network address translation or source address network translation. Here you can see a lab topology, which we'll be talking about in this video series. There are 3 videos in this series, and they're focusing on different scale and different types of deployment where the Source NAT is being used. One is a low scale, home office, or small business. This is the type of scenario we'll be looking at in this video. The products which I'm using in this topology are virtual SRX and virtual MX. These are Juniper firewall and router. The code versions are mentioned here. There is also in the middle you can see the test target server, which will be directing our test traffic. We'll start with covering a feature available on the Juniper SRX firewalls, which is called port overloading factor. This is a setting which can be applied for the interface NAT or for a certain pool, and it affects how pool is utilized and how scalable the pool is. Let's say we will set at the example of just one IP address. If you don't use port overloading factor, which equals it set to 1 by default, you have a general pool containing all the available ports for you for your translations. And when the session is being ready to being established, it just takes one address from the pool and being translated. And the example, if the port overloading factor is set to 4, this is when there are basically 4 copies or 4 subpools are created containing all the available ports for that one IP address in this example. And then there is also additional step in the process by doing the certain hash operation on the destination address and selecting which pool this specific session will be using a port from. And basically, it gives us the possibility to increase the potential pool size by not increasing the IP addresses in the pool itself. And as a result, at the same time, there can be multiple sessions using the same port for translation. And every single session will always, based on the hash algorithm, will always hit just one of these pools, not multiple. And you can also influence the number of these pools, which can be set by this factor. It can be from 2 to 32. Let's look into the pool depletion scenario, because there is important and there is a difference here between the two approaches. The first approach is very simple. If all the pool ports are shared, it means as soon as they are depleted, the session is dropped and no more sessions can be established. But in case of the overloading factor use case, remember the hash algorithm. So different sessions are being hashed to a different subpool. And if you have high utilization on one of the pools, let's say one pool is depleted, all the sessions which are based on the hash algorithm are hitting this pool will be dropped. The sessions will not be using ports from other subpools, even if there are available ports still there. So this is something to remember. So how can we scale it? We can. So basically what can be done, if you increase the pool size to 2 addresses from 1, you increase the available port density, right? 2 times up to 124,000. And it basically will be in every subpool. Increase will be in every subpool, so which is great. But there is a catch. The maximum interfaces in the pool with a non-default overloading factor depends on the Juniper SRX model. And on the branch series or the virtual product, it is limited to 1. In the data center product, it starts increasing. Like in 1500, you can create a pool of 2 addresses and apply non-standard factor to it. Or big boxes like ISP and data center scaling, they can do up to 128 addresses. And there are actually fun facts. A pool of 128 addresses can give you potentially just shy of 8 million sessions for NAT translation. But if you have, let's say, SRX 4600 with the same pool of 128 addresses, but with the port overload factor enabled to 32, the maximum value, you have a theoretical pool size of over 255 million sessions. This is something very important for the ISP scenarios like carrier-grade NAT or CGNAT. We'll start with home office, small business use case, scenario 1. In this case, we have a test PC with a private address, which will be addressing our test server in the internet. We have our virtual SRX over here with the uplink connected to the internet service provider. Internet service provider dedicates a certain subnet, in this case /28, to provide IP addresses to individual customers. In our case, .1 address is assigned on the provider side, and .13 is assigned on the customer side. There are 2 types of addresses which are reserved and cannot be used to assign to endpoints. One is called a subnet address, the first one from the pool, and the last one is a broadcast address. So if we look into the subnet size, we can compare it to a /30 subnet, for example. In this case, in the /30 subnet, there are 4 addresses, 2 of which are reserved for the same reason, and there are only two addresses available to assign to any hosts. And it gives a 50% use efficiency, right? Because only 50% of the IP space is capable of being assigned to the network devices, while in the /28, the efficiency is 88%. So the bigger the subnet, the more efficiency. So that's why we will tend to see larger subnets. when you communicate to the ISP. In this scenario, we'll be using something called interface Source NAT. In this case, all the traffic from the private address will be translated to the public address of the outgoing interface toward the provider. Some specific use case facts. The routing will be static. It's non-redundant forwarding schema because we have just a single ISP and single router. The net type is interface, and the pool size is 62,463 sessions. And we don't use port overloading factor feature, which we'll describe in detail a little bit later. There are some general facts which will be general for every single lab scenario. We'll just go over it once. The port randomization is enabled by default. Each new session gets a random port from the pool, not sequential. So this is done for the security reasons. It is enabled by default. The port ranges for Source NAT by default are ports from 1024 to 63,487 are used for a port translation. So this is something we target. These are our ICMP, TCP, UDP traffic being translated. There is also a reserved range from 63,488 to 65,535 for the twin port. So twin port are used for a special kind of RTP applications like SIP or H323. So port range is customizable, but you cannot increase, you can only decrease certain ranges here. And also ports from 0 to 1023 are never used for Source NAT. It means that you can use every single IP address you use for the Source NAT for the destination NAT as well, for in the reverse direction to translate or pass through services like HTTP, SSL, or SMTP. So let's start with checking our configuration, and I will briefly go over. So this is the SRX, the virtual SRX for the home office environment. So we'll look at the Source NAT. So in this case, we have just single rule set and the single rule, which basically mentions the interface as an action. I have wide open security policy, and I have two security zones, trust and trust, and then we have basically our interface settings. Let's go and start checking our NAT. We'll start with show security NAT source summary, which will basically show us the whole summary of the NAT solution. It will say that we have certain policy which is mentioning the action interface. Next step will be show security NAT source pool, and it will show us that there are no pools. So the reason behind that there are like two separate entities. So when you put an interface as an action, it does not automatically create a pool for you. In this scenario, there is no need to create a pool. It gives even advantage to use interface for the scenarios where your public ISP address is a dynamic. So it can change over time. It is obtained by DHCP, for example. So the interface is a better option. It's just the comment, so why you don't see a pool over here. So the next step is show security NAT source rule. This will give us a little bit more information. It will tell us what source addresses are we matching for the translation and so on. And another useful thing, you can see translation hits and successful sessions, so which are actually using that rule. So it can give you a hint whether your rule is actually working or not. Do you have a traffic or not? So the next step, I'm going to my test PC, and I'm going to start ping to my test server. The first host will be sending the ICMP, and the second I will set to send TCP ping. which is basically opening a three-way handshake TCP connection and then closing it, etc., and gathering statistics. So now we are going back to our firewall. First of all, we can see that it is successful. So the traffic is going through. This is the first step of verification, and then we are going and doing show security flow session. And here we can see some ICMP sessions, and then we can see our TCP session as an example using a port 7. So the important thing is that we can see a source address for the clients, we can see a destination address in the internet, and then we can see that the session basically consists of two lines. So one line is one direction and another line is reverse direction. And in the reverse direction, actually the server is responding to us, but the server is responding to our public address. So this is the actual NAT, right? So we always check addresses cross. So we can see that the private address has been translated to this address and to this port from the pool. Another quite useful thing is to basically check our session table a few times. And then we can notice that this was translated to 23,770, and over here it was 28,542. So we can see that this is the port randomization in action. But yeah, so this is the simple use case. The NAT is working. So we have already discussed the pool size. So yep, let's continue to the presentation. Let's continue with the home office small business scenario 2. This scenario is almost identical to scenario 1. The difference is that for the interface pool, we enable port overloading factor to 2, which increase the pool size twice. So first of all, we'll start with the configuration. Again, I'll show you the full configuration for your reference, but I would like to highlight next thing. So the difference from the first use case is the port overloading factor. So basically just a single line difference from the previous one, right? And it enables the port overloading factor logic with the two clone pools or sub pools. So we'll basically go in the same sequence. Show security net source summary. Yeah. Then we'll do show security net source pool. Again, there are no pools, right? As I mentioned, because we use interface NAT, right? By using that source NAT interface. Show security net rule all. Source rule all. So in this case, we basically see identical output, right? It doesn't mention anywhere the port overloading factor, but we also see some translation hits, so that the session or the rule was working. Yep, so next we'll do identical things. So we'll start ICMP ping from the first host, it is successful, and then we'll start TCP ping from another one, it is successful. So now we'll do show security flow session. And we'll have a look. Yeah. So we see our TCP. Again, we check cross. So this was the internal private address translated to a public address. For the ICMP, same idea. So this was internal of the client one, and then it was translated to this public address, right? Which is our interface, public interface address. So this is it, our public provider-facing address. Here we are. Thank you for watching, and I hope you learned something new or useful today. See you in the next video.